because it's all about exponent laws. Okay? Basically, at the end of the day, we are going to take exponent laws and what you know about the exponent law rules or what have you, and we're going to put them on steroids. Okay? We're going to give you some different. We're going to give you some different problems, some different curveballs, and we'll see how you handle it. But just to make sure, I want to make sure everybody is aware of the basic exponent laws that we've learned from last year. When I have a situation that looks like this, x to the power of 3 times x to the power of 4, and I want to turn that into one power, so 1x and 1 exponent, how can I do it at first? Can I make that into 1 exponent or 1 power?
Yes.
Why?
You can add the exponents.
Why can I add the exponents? I have the same base. I have both bases that are x. Now, because I'm multiplying, someone said it earlier, because I'm multiplying those two terms together, what can I do with the exponent?
Add them.
I add them together. What's 3 plus 4?
7.
7. This process works for every single term as long as the bases are the same. Got it? So when they're multiplying, same base, I can add them. What do I do when I'm dividing? If I have x to the power of 4 divided by x to the power of 3, I can still write x because they have the same base, gentlemen. Last time, and I'll pop in every single one. What do I do now with the exponents? Subtract them. 4 subtract 3 is x to the power of 1. Okay? Sorry? And then you could just write x, absolutely. Okay? Everybody's good with that stuff so far, right? Next one. If I have power of power, x to the power of 2 in brackets to the power of 3. Anytime I have two exponents that are separated by a bracket, what do I do with those two terms? I am multiplying them. If I want to get rid of this bracket, what does my term equal? X to the power of 6, 2 times 3. Good? Alright, wonderful. We're flying. Power product law. I have, actually, let me do this one. 3x squared. Is this answer 9x squared or 3x squared? I want everybody with their markers to write it down right now on their board. What do you think the answer is? 9x squared or 3x squared? Go.
I didn't get a marker.
You didn't get a marker. Catch up. Zach, do you have one?
See that catch?
It was pretty sweet. Anybody else need one? Oh.
The nub.
Which one do you think it is? Okay, how many people think it is 3x squared? Hand up, just out of curiosity.
Wait, what?
Which answer do you think this is? 3x to the power of 2. Is it 9x squared or is it 3x squared? I'll give you a minute. I want you to think about this. If you're not sure, that's fine. I want you to take a guess. I want you to take a guess. When in doubt, pick C. You've ever heard that saying before?
You know, one of the guys from Duck Dynasty fell asleep during one of his finals and he picked C for every answer and he got like a 95.
In theory, if you do that, if there's four answers, you should theoretically get 25%. Right? You get 1 in 4 chance.
Yeah, but he got like 95.
Okay, if we move quickly along here, how many people think it is 9x squared? Put your hand up. How many? Good. How many people think it is 3x squared? Put your hand up. This is what Kara put down. When in doubt. All right. To remind you what the power of a product law is. When I have two terms, 3 and x, I assume that they are being multiplied because there's no space in between them. Or there's no operation between them. With this exponent, I actually have to take this exponent and put it into both terms. So I actually have 3 squared times x squared. Who can tell me what 3 squared is equal to? Who can tell me what x squared is equal to? X squared, which is my answer? 9x squared. Power of a product rule, I have to put the exponent into both terms, regardless if it's a variable and a number, number and a number, what have you. Alright? Good with that? So having said that, what about if I have something that looks like this? X to the power of 4 squared. What is this answer? X squared over 4 or x squared over 16? Which one is it? You're allowed to guess again if you want to. But I want you to tell me why you think it's that. What is it? Anybody think that it's still x squared over 4? Why is the answer x squared over 16? Doran?
Because when you put the exponent on both of them, you end up with x squared and 4 squared. 4 squared x.
How this looks, again, same process, even if I'm dividing. I have to put that exponent into both of them, so it looks like this, x squared over 4 squared, which gives you this. So far, so good? Alright. Now, here's where we start seeing some curveballs. Up to this point, we have been dealing with exponents that are positive and exponents that are bigger than 1. Correct? So, my question is, what happens when you have exponents that are not a whole number, and specifically if they're less than 1? Every single number that we deal with can be represented as a power, as well as a fraction, as well as a radical. Today's lesson is not based on a skill that you may need to use tomorrow. You're going to say, oh, thank goodness Mr. Dillon told me about these exponent laws. But it's something that it's going to gain you confidence in manipulating and using numbers in the way that works best for you, whether you choose to go into high-level math, calculus, sciences, whatever, or engineering. I compare it to, maybe not everybody likes to dance or play sports or do a certain activity, but if it gives you more confidence in your ability physically, you're going to do it. Same thing is going on here. You may not use this tomorrow. Not everybody's going to play lacrosse, but you play the phys ed. Or not everybody's going to dance for the rest of their life, but you also do that in phys ed. We may not use fractions as exponents, but to be able to manipulate the number as we want to use it is a benefit to us. So when you see a power with an exponent less than 1, I want you to start thinking about how you can convert this. Basically, all exponents can also be written as a radical. Anything with an exponent can be written as a radical. So in this example, for 25 to the power of a half, I can actually write this in and convert it to a radical. We all know how to deal with radicals. We've done square roots, cube roots, fourth roots last day, correct? How this looks is I always take the base number that I'm dealing with, and I put that inside my radical. Okay? Now, here's where I split up my exponent. The numerator in my exponent always goes to as the exponent inside the radicand. So I sneak a little 1 by that radicand. Okay? So it's 25 to the power of 1, which is just what? 25. What do I do with that 2? This bottom denominator actually becomes the index. You remember the index? It tells you whether a radical is a cube root, square root, fourth root, fifth root, whatever. Because this is a 2, what type of a radical am I dealing with now? A square root. What is this radical telling me to do right now? Or what's it asking me? What is the square root of 25? Or specifically, what number multiplied by itself gives me 25? What number is it? 5. Here's how I check. I'm not, in full disclosure, I'm not specifically, unless I ask, solve this problem. I really just want you to show me the ability that you have to convert from an exponent into a radical. If you show me this, all is well. If it works out that it works evenly, that's gravy. But this is the important stuff that I want you to see. how I can check to make sure my answer is correct is if I put 25 to the power of 1 divided by 2, which is what we had, I know it's 5. And we already know that the square root of 25 is 5, right? So again, you're showing different ways to represent a number. In this case, I've showed you 3 ways to show the number 5. The number 5, the square root of 25, and 25 to the power of a half. Everybody good with that so far? Okay, I want you to show me what 8 to the power of a third looks like as a radical. Can you solve it? Can you get an answer out of it or not? Good. Okay, try the next one. 16 quarter. 4. No, not 4. 2. Show me as a radical. 2. Show me as a radical. 16. The next one. 16 to the fourth. Yep.
Should I do the fourth one?
No, I want you to do, try 9 to the power of 2 over 3. You need enough to get that on your calculator if you got math. 3. So it's number 4. Use a little 4. And then if you ever get one that goes you to the 4th, you can actually go this one with a little X, number 5. It can let you fill in whatever number it is. Good. Try 9 to the power of 2 over 3. Tell me what happens. Good. Try the next one. Try 9 to the power of 2 over 3. Good. Yeah, no, it just gets it.
Oh no, I'm gonna
Okay, try 9 to the power of 2 over 3.
But that's not your answer.
Hi guys.
It's like part of the process.
Okay, show me the radical. I don't care about the answer. I care about
So
showing me
then
what the radical
2
is.
is
I know the radical.
so square root 25 is 5. So what's the
Yeah, the square root.
What's the
Show me what's
cube?
either is the fourth piece.
And then the cube is 8.
You're gonna come to realize that I do that into something that's like versus the answer. I care about the conversion being able to do that. Not, yeah, the answer is great, just like I said. Now do 9 to the power of 4 piece.
I don't have my calculator.
Rip my brain. Try 16.
It's not.
So try the next one. The next one 16 to the power of 4. Try 9 to the power of 2. 9 to the power of 2.
What you do is you do something weird.
Then he wants to do
Okay, so here's my
quarter and then 9.
suggestion. Can you reduce because it's a decimal, so we're going to leave it in radical form, right? As soon as we see decimal, decimals are bad. We want to keep it kind of in radical. Can I simplify anything? Nope. Sorry, simplify it. Can I get rid of it? Yeah, I would get rid of that 9 square. What would I write it as? So instead of writing 9 square, I would just
Well, that's what you just.
that's fine. So as your final answer, it would be the cube root of 8. Yes, but I don't. If it gives you a decimal, leave it as a radical. Nope, leave it as a radical. Your final answer.
Wait, I get it.
No, it would just be this. That's it. That's all I want. Because, like I said, we've always said which is more accurate, fractions or decimals. Fractions. Radicals are the same. Which is more accurate, decimals are radicals, fractions are radicals. Okay? Yes, but okay, this is good. Okay, very quickly, because I see quite a few of you with it. This answer is the cube root of 8. This is the 4th root of 16. If I was asking you what these answers were, they would both be 2. Right? But as I talked to a couple students already, I'm more concerned about your ability to take this guy and write them out. I know the answer's 2. Honky dory, I'm not really worried about it. I'm worried about your ability to convert a exponent into a radical. Yes, Stephen? 9. Okay, perfect. I'm going to actually share that with everybody because there's one little curveball that I'm just starting to discover. Okay, let's stop bumping. Okay, Some people got a question like this that I asked. They said, tell me what the radical of 9 to the power of 2 over 3 is equal to. What goes inside the radicand? What number? 9. What number goes in as the exponent? 2. What number goes in the index? 3. Now, is there anything that I can simplify or get rid of in this example? I can get rid of that square. I can turn 9 squared to equal what?
81.
The cube root of 81. Alright, what happens, Kara, when I take the cube root of 81? What do I get for an answer? 4.3 what? 32? And did it go on forever on your calculator?
Yeah.
Yes, so you gave me an approximate answer. Remember the question I asked you, which do I prefer, fractions or decimals? Why? Fractions are more accurate. The same can be said about radicals, okay? If you are given a final answer and it is a decimal and it came from a radical, leave your final answer as a radical. Cube root of 81 is much more accurate than 4.32. I'm looking more for the process. I'm not looking for a final answer. This would be gravy for me. This would be good, okay?
So that's a way to represent an irrational number, like in a finite amount of space.
Yes, exactly. That would be a perfect analogy. I'm turning an irrational number with no pattern into something that is not ridiculous, and it's still accurate because it gives a good representation of that number. Absolutely, great analogy. Okay, now I'm going to scrap this question, and I want you to think again. Same trend. I want this time 3 over 5, and I want you to try these next examples: 0.04 to the power of 3 over 2, and 3 over 8 to the power of 2.5. You are going to notice a curveball in the third one that you're going to be like, what's going on? I want you all to try these ones, okay? 9 to the power of 3 over 5, 0.04 to the power of 3 over 2, and 3 over 8 to the power of 2.5.
I honestly said 16 plus 6.
This is 0.04.
Mr. Dillon,
Yep.
they trying to solve that.
Yes.
81 times 9, yeah. Yeah,
No idea.
All they did was 8 times 9.
To find the 3 was
What do we do? Okay.
Okay.
for you.
Which one do we do?
Remember, I want to get rid of those.
Wait, which one?
Get rid of that 9.
Oh.
You don't have to go any further
Oh.
than this.
No, if it gives you a decimal, which I believe it does, I believe it's 7.
9.
They want you to fill in.
729.
What is that?
But is it something that I could break down?
Yeah, well, it's fact, it would be if you do factor between nines.
Yeah.
It would be a bunch of
does
ones. It would be 2, 4, 6, 3. So you wouldn't have it. It would be, and actually, as a mixed radical, it would be 3 root 3.
I got 3 points.
3 to the 5th root. Again, so that's the 4th way to represent something. Yep. Uh-huh.
Can I erase it now?
Yeah, absolutely. Go on to the next one. Okay, so the only thing, you can't find an answer from this, but I can simplify this part, right?
Like from like how do you find like 2, 9?
Oh, that's not a 9, that's a 4. It's basically I'm asking you what's the number if I multiply by itself 4 times that gives me 16. In that case, it would be 2. If you have your calculator with you, I can show you how to do that. Okay, start bringing your calculator, and I can show you that. For now, don't worry about it. I'm worried about that answer. Okay, but then I would just change this 9 times 9 times 9, which is. Okay. Sorry, he had asked, and then I'm going to. You need to change it to a fraction that's not 0 for 2. Check back what your fraction is. 2.5. 2.5 is not 0 for 2. That's 1.5. But you're on the right track with 5.
So Eric,
No.
here's a question for you.
Figure out what that fraction is. Once you get it, then you get it. Okay? I don't want it. Oh, hold on.
If you were to break that number down into prime factors, what would they be?
That's when you have to
No,
go
because
back.
9 is not a prime factor. What are the prime factors of 9? Because this is just 3 9s multiplied together, right? So what are the prime factors of 9?
So where do you leave it?
And how many 3s are the prime factors of 9?
Good.
Yeah, but that's adding and multiplying.
Yes, gentlemen?
So we have 3 9s, 2 3s in each 9. So how many 3s do we have?
I go 0 from 0 for, but I get.
Yeah. 6.
And then I try to, okay, I'll kind of pop those 3 together. And
3 times 3 equals 720.
Yeah, that's the one.
I was actually static by rubbing it on my wool sweater. Yeah, and then I put it on my.
You could, if I was looking for an answer, yes, but I'm not looking. I'm just looking for the radical form.
You want to see some awesome science?
You can
I rubbed
Did you
this on
steal
the.
my balloon?
No, Eric did. But I rubbed this on my wool sweater and then put it on Zach's
You can
hair
wave
and
the
messed it
camera
up. Look at this. I'm rubbing a balloon on a wool sweater.
Oh, yeah.
I can pause it.
What's 6.4 to the power?
I wonder if I can.